Today's lessons will be on tangent lines with circles. So before we begin, I just want to go over briefly the parts of a circle that you should already be familiar with. You should know a radius and diameter. Okay. You should also know area and circumference formulas for a circle. So remember that A to C segment is our radius, because a radius goes from the center of a circle to the circle. So center of the circle to the circle is a radius. You should also know what a diameter is. So D to B is our diameter. And diameter is a segment that goes from one side of the circle to the other and passing through the center of a circle. Okay. And then you should also know that your formulas for area of a circle. You should know that area equals pi r squared. And the circumference, which is distance around a circle, is equal to 2 pi r, where pi is approximately 3.14. So this is stuff that you should already know, okay? Basics information about a circle. Radius, center of a circle to the circle. Diameter, D to B, that's going a segment from one side of the circle to the other and passing through the center. And you should know area, which is pi r squared, where r is the radius. Circumference is 2 pi r. Pi is 3.14. And don't forget, you also have circumference can be pi times d also. You should also know that diameter is equal to 2 times the radius, and then the radius is equal to the diameter divided by 2. Okay, this is all prior knowledge that you should be familiar with. So let's begin. Tangent lines and circles. You have to know what a tangent line is, and our objective today is to use properties of a tangent to a circle. A tangent to a circle is a line in the plane of the circle that intersects a circle in exactly one point. The point where a circle and a tangent intersect is called the point of tangency. So in my diagram here, I have ray BA is a tangent ray to segment BA, and they're tangent, okay? So BA ray is a tangent ray and BA is a tangent segment. So again, if you have a line or a segment or a ray that touches a circle once and only once, it's called tangent line or tangent segment or tangent ray. So a radius of a circle and the tangent that intersects the endpoints of the radius of the circle have a special relationship that we're going to find here. So again, tangent lines, okay? Tangent lines, they touch the circle at one point, okay? Only one point. So if it touches the circle at 2 points, it can't be tangent. So make sure you understand your vocab of tangent to a circle and what point of tangency is. So where the line and the circle meet is the point of tangency. The tangent to the circle touches the circle once and only once. So here B is my point of tangency, A to B or B to A is my tangent line. So here's our rule, okay? If something is tangent, or I should say if a segment, line, or ray is tangent to a circle, okay, then it's perpendicular to the radius, okay? So here we have A to B. It's tangent. I know it's tangent because it only touches the circle once and only once. Therefore, if it's tangent, okay, A to B is tangent. Therefore, the intersection, or I should say, the intersection with the radius is perpendicular. Okay, so if tangent, so easy way, so if tangent, then it's perpendicular to the radius. How do you know if it's tangent? Tangent is touch once. So why do we need to know this? Because more often than not, we're going to be creating some right triangles, and we have been studying triangles forever in geometry. So let's do some examples. So ML, MN are tangent to circle O. What is the value of X? Okay, well, you know that now. Tangent, okay, means they touch once. And if it's tangent, you know that they're perpendicular to the radius, okay? If you have a radius, you know the radius is from the center of the circle to the circle. So I know the red lines are my radius. I know that LM is tangent. I know MN is tangent. So from our previous theorem, if something is tangent, okay, line, segment, rays, tangent, it's going to be perpendicular to the radius. So I know that angle L is 90 and angle N is 90. And I'm not asking for the value of R, I'm asking for the value of X. I'm looking for angle M. Well, I'm going to highlight a four-sided figure. You should know that a quadrilateral has 360 degrees. So a quadrilateral is 360 degrees for the interior angle sum. So I have 117 plus 90 plus 90 plus X equals 360. So now I can solve for X. I have 117 plus 180 plus X equals 360. So I have 117 plus 180. I have 297. So I have 297 plus X equals 360. So I have 360 minus 297, and I have X is equal to 63. So you're going to have to know your rules of triangles and also know your rules of polygons. So again, if a line, ray, or segment is tangent to a circle, meaning it touches the circle once and only once, it's going to be perpendicular to the radius. Okay, here's the second example. EG is tangent, so I know this is my tangent. How do I know? It tells us. So if this segment is tangent, I know it's perpendicular to the radius. Well, here's my radius. OD is my radius, so I know that angle D is 90. Now you should see a triangle. Okay, I'm going to highlight it for you. So here's my triangle. How many degrees in the triangle? 180 degrees. So I know that I have 90 plus 38 plus X equals 180. So I have 128 plus X equals 180. So then I have 180 minus 128. I have 52. So X is equal to 52. So segment, line, or ray tangent to a circle, touches the circle once, therefore it's going to be perpendicular to the radius. So you can actually apply this in some application problems. Okay, the CN Tower in Toronto in Canada has an observation deck 447 meters above ground. About how far is it from the observation deck to the horizon? Earth's radius is about 6,400 kilometers. Make a sketch. The length is 447 meters, which is about 0.45 kilometers. Technically, it is going to be 0.447 kilometers. Okay, meters to kilometers. Divide by 1,000. Okay, so here is my radius. I have this distance, 0.45. I have my radius, okay? So I know that this is 6,400. I know that this is 6,400, and I want X, which is e to t. So I'll redraw my triangle. Okay, and I'll rotate it. This is kind of what I have here. So I know that this is 90 because angle E is 90 because something that's tangent is perpendicular to the radius. here's my radius, so this is 6,400. Okay, here's C, here's E, here's T. I'm going to call this point Q right there. So here's point Q. Point Q is 0.45. Okay, C to Q is my radius, so that's still 6,400. I want X. Okay, so I'll right triangle. I have two given sides, therefore I can use Pythagorean theorem. Okay, so I have X squared plus 6,400 squared equals 6,400.45 squared. So X squared equals, so I have 6,400.45 squared minus 6,400 squared. So X squared is going to equal 5760.2025. So X is going to equal the square root of 5760.2025. So I take the square root. Of that. Sorry, 5760.2025. It's about 75.90. So I have 75.895. Okay. Kilometers. So using tangents and right triangles and Pythagorean theorem to solve for a distance. Again, remember T to C is not 6,400. T to Q is 0.45. Q to C is 6,400. So let's try another example. So I have someone on Earth. Okay, what's the distance to the horizon that a person can see on a clear day from an airplane 2 miles above the Earth? The Earth's radius is about 4,000 miles. So in this case, my radius of the Earth is 4,000. Okay. I'm 2 miles above the Earth, so I'm going to do that in red. So this is 2 miles. I want to know how far can I see? Well, this is going to be my blue. Okay. I want to know how far. Here's my little airplane. Here's my airplane. I'm 2 miles above the Earth. I'm looking across the horizon. How far can I see? I know that the Earth's radius is about 4,000 miles. How far can I see? Again, that's X. Well, the line of sight is going to be tangent to the radius of the Earth, so I know that this angle D is going to be 90. Here's C, here's B, here's A. I have a right triangle. Okay, so if I have a right triangle, let's recreate the right triangle. Here's D, here's C, here's B, here's A. A to D is what I want to find. I know this is 4,000, this is 4,000, C to B, and B to A is 2. So Pythagorean theorem, I now have X squared plus 4,000 squared equals 4,002 squared. So X squared equals 4,002 squared minus 4,000 squared, which is not 2 squared. Order of operations, do exponents first. So I have 4,002 squared minus 4,000 squared. I get 1604. So x is the square root of 16004. Which is about 126.506 miles. So using tangents and Pythagorean theorem. Now you have to know if something is going to be tangent. Okay, how can you solve for radius, or how do you know if something's tangent? Well, you know if it's perpendicular, it's tangent. Okay, so AB is perpendicular to OP at P, therefore AB is tangent to O. So if you know that a line that touches the circle once touches the radius and intersects the radius at 90 degrees, it's going to be tangent. So let's apply this. What's the radius? So let's apply this again. So I know OBA is a right triangle. So O to A is my hypotenuse. So I'm going to use Pythagorean theorem. X squared plus 10 squared equals parentheses x plus 6 squared. So I have x squared plus 100 equals x plus 6 times x plus 6. X squared plus 100 equals distribute. Okay, or if you want to FOIL, I have x squared plus 6x plus 6x plus 36. So I have x squared plus 100 equals x squared plus 12x plus 36. I'm going to minus x squared from both sides. So now I have 100 equals 12x plus 36 minus 36 from both sides. Okay. I have 64 equals 12x. So 64 over 12 is going to give me 16 over 3. So x equals 16 over 3. So let's apply Pythagorean theorem and see if we have tangent. So I want to know, is ML, I want to know, okay, is this a tangent line? Well, if it's tangent, it has to be 90 degrees to NL. Well, if this is 90 degrees, it's going to create a right triangle. Well, how do we know if a right triangle is true? Well, we have to test to see if Pythagorean theorem is true. So remember, from our triangle, if a squared plus b squared equals c squared, we have a right triangle. And remember that c squared, or I should say, c is always the longest segment or longest side in any triangle to see if it's going to be a right triangle. So how do I know if this is going to be tangent? Well, it's going to be tangent only if we have a right triangle, okay? So is this, so then I have to test, okay, do we have a right triangle? If yes, then M to L is going to be a tangent segment. So let's apply this. So I'm going to check, is 7 squared plus 24 squared equal to 25 squared? Well, I have 49 plus I have 24 squared, which is 576, 576. And then I have 25 squared, which is 625. And then if I add 49 plus 576, I have 625. So it's true. So yes, ML is tangent. So yes. Why is it tangent? Because we have a right triangle. And the tangent line is touching the circle once and only once. Now, if I asked you is m to n can never be tangent. I agree it touches it once, but also it goes through the center of the circle. So remember that a tangent line, I should also add that tangent, will never go through the circle. So to determine if something is tangent, you have to do Pythagorean theorem. Here is another segment rule for tangents. If BA and BC are tangent, then they also meet at a point outside the circle, then the segments are going to be congruent. So if you have two tangent lines that meet at a point, in this case B, then those tangent segments are going to be equal. So B to A and B to C are equal. Why? Because they all meet at B outside the circle. So how does this help? Okay, we've actually seen this with the incenter of a triangle. So here, if I tell you that A, B, and C, so if I tell you that A to B, and I tell you that B to C, and A to C, these are all going to be tangent lines, okay, then I know if those are all tangent, the point of tangency, so if I have Q, R, S, then I know I'm going to have some congruent segments. So I know that A to Q will be the same, A to S will be the same. I know B to Q and B to R will be the same, and C to R and C to S will be the same. I'm not saying A to B is equal to B to C or A to C. So from an angle outside to the point of tangency, okay, they're going to be congruent segments. So in this case, I want to know perimeter. Perimeter is basically add up all sides, okay? Perimeter is distance around an object, okay? So if something's inscribed, I know that I have tangent segments, okay? So I know that, okay, in this case, inscribed, I know that A to B, I know B to C, and C to A, they will be tangents. So if they're tangents from the angle A to D and A to F, the points of tangency are going to be equal. So I know that this is going to be, I know that those are equal. 15, these are equal, and those are equal. So I know this is going to be 10, this is 8, and this is 15. Because from the angle, the points of tangency meet on a point outside the circle to the points of tangency, they're going to be congruent segments. So 10, 10, 15, 15, 8, 8. So I know the perimeter is going to equal 10 plus 10 plus 8 plus 8 plus 15 plus 15. So the perimeter is 20 plus 16 plus 30. Okay, so I have 20 plus 15 plus 30 is 65. So the perimeter is 65 centimeters. So the circle is inscribed inside of a triangle. I'm going to have tangent lines, so I know that, okay, P to Q, I know P to R, and Q to R, these are tangents. If those are tangents and I have a circle that's inscribed, I know that P to X is equal to P to Z. I know Q to X is going to be the same as Q to Y, and I know R to Z is going to be the same as R to Y. The reason why I know those segments are equal, okay, or congruent, because I have an inscribed circle inside of a triangle. So this is 15, this is 17, this is going to be, I'll call this T and T, they're going to be equal, okay? I already know the perimeter is 88, so I have 15 plus 15 plus 17 plus 17 plus t equals 88. How do I know it's 88? Because the question already tells me that the perimeter is 88. Find the values of qy. Okay, so I have 30 plus 34 plus 2t equals 88. So I have 64 plus 2t equals 88. So 88 minus 64 gives us 24. So I have 2t equals 24. T is equal to 12. So q to y is 12, and q to x is also 12. And that concludes the video lesson. Here are some problems that you should practice on your own. If you have any questions, please ask or send an email.